Hi guys, I'm Srimati from AIT. I belong to School of Electrical Engineering. My specialization is power electronics and drives, and my research area includes embedded systems, microprocessor based embedded systems, microcontroller based embedded systems, DC-DC converters, energy conservation, IoT based systems, and programming by using microcontroller and microprocessor. And during the semester, I'm going to take this basic electrical engineering. The course code is EEE101L. Coming to module 1, it is all about DC circuits. Okay, before going into your module, I need to tell you about the objective of this particular unit. Okay, so the only two objectives I have mentioned here. This two objective will be common for unit number 1, 2, and 3. Okay, and unit number 1 and 2 is for DC circuit and AC circuits. Number 3 is for magnetic circuits. Number 3 is for magnetic circuits. So the objective is provide insight into concepts and principles in electrical engineering and understand and comprehend the laws, rules and theorems used to compute the parameters of electric circuits. And coming to your outcome for course outcome, what we expected from the student end is nothing but you need to analyze and evaluate the DC and AC circuit parameters using various laws and theorems. That is the outcome that we are expecting from unit number 1 and 2. That is said to be course outcomes. Okay. And coming to your module number 1, it is DC circuit. It is DC circuit. And the subtopics that is being involved here is basic circuit element and sources, Ohm's law, Kirchhoff law, series and parallel connection of circuit elements, source transformation, node voltage analysis, mesh current analysis, and maximum power transfer theorem. And most of you would have encountered all this that words in your physics, like your elements, sources, Ohm's law, Kirchhoff law, the same thing that we have to brush up, and then we have to go ahead with the analysis of electric circuits. Okay, so let me go ahead with the circuit elements and sources. What is mean by a circuit element and sources? Okay, so circuit elements, you have RLC is said to be your circuit elements. Okay, so R, L, C, and sources are said to be circuit elements. Before going into detail about your circuit elements, let me tell you what is meant by a circuit and a network. Okay, so what is a circuit? So circuit is nothing but you will be having a combination of RLC and sources. For example, let me take the circuit. I have an R here, L here, and L and C here, R and C here. Okay, this is a circuit. So circuit, this is an voltage source. So the circuit R1, R2, L, C. Okay. So if I take a circuit, I'll be having a closed path here. I'll be closed path for the current flow. Closed path for the current flow. Like this it may flow, and like this it may flow, and like this it may flow. Okay. So I may have closed path for the current flow. That is said to be a circuit, and this circuit is made up of circuit elements RLC and your voltage or the current source. Need not be necessarily the voltage source, it can be the current source also. And it is not that each and every element will have the combination of RLC. Then you may have RL, RC, and RLC, or simply RL. Network is nothing but, let me take this as circuit number 1. Okay, so network is nothing but you have quite large number of circuits, namely n number of circuits starting from 1, 2, 3 up to n. Okay, it's a large number of circuits connected together, namely the first circuit and second circuit and third circuit. Like that, it goes on and on. 2, 3, like that, it goes on and on. and we cannot say that it may form a closed path. It may form a closed path. That is the difference between a circuit and the network. One such example for network can be a transmission and the distribution network that is running across the street for delivering us the power. Okay, the transmission and the distribution network. Okay. Electrical network. So that is one example of your network. You have n number of circuits. These circuits is nothing but a home. Namely, you have n number of residences. Each circuits will be connected to the distributing line. Okay. So first home number 1, home number 2, home number 3, and each and every homes will take different types of loads and different types of current. Example. This is an example, and that is in case of your distribution network. So you have n number of circuits that is connected together, that is said to be a network. This is the primary difference between your circuit and the network. And coming to your circuit elements, okay, R, L, C are said to be, and the sources are said to be your circuit element, and sources are said to be your circuit element. And you know that what is your R is an energy dissipating element, and L and C as energy storing element. One will store energy in magnetic field, and another one will store energy in the electric field. That is regarding your L and C. So these are the circuit element, and other circuit element is sources. Okay, sources is again classified into two different types. One is independent source and another one is dependent source. Okay, dependent source. So independent source will be represented by a circular symbol. Okay, independent source. And number two, dependent source will be represented by a diamond symbol. Okay. And again, this independent and dependent sources are classified into voltage source and current source, voltage source and current source. Okay. So now, why am I telling this as independent sources? For example, let me take an independent voltage source and we having a circuit here. Okay. Whatever may be the value of resistance R1, R2, R3, this voltage value won't change. It will be stiff. This voltage value is not dependent on, it does not dependent on any other element or any other parameters, namely your current or voltage across each and every element. Okay, any other element in the circuit. So the voltage value will be stiff. Similarly, instead here, if I have a current source will be represented by an arrow, either an up arrow or a down arrow. Similarly, the voltage source can be the top may be positive or bottom may be positive, vice versa. So you have a circuit like this, okay, circuit like this. If this current value does not change, it is not dependent on the elements R1, R2, okay, and it is going to be stiff in nature. That is said to be independent voltage source or independent current source. I'm sorry, independent current source. That is all about your independent voltage and the independent current source. Coming to your dependent sources, again it is classified into two, voltage source and current source. Dependent voltage source and current source, it is classified, both of them, it is classified into four classification. One is voltage controlled voltage source. I'm telling about this. And another one is voltage controlled current source. And next is current controlled current source, current controlled voltage source. Okay. So let us see in detail of all the four things in the next slide. Okay guys, so when coming to your voltage controlled voltage source, it is an voltage source. It's an voltage source controlled by another voltage parameter or a variable where V1, 3V1, where V1 is the voltage across this 5 ohm resistor. So the voltage across this 5 ohm resistor is going to decide the value of this voltage source. So hence it is said to be voltage controlled. It is controlled by the voltage variable V1 and it's an voltage source. Okay, it's an voltage source. Hence the name voltage controlled voltage source. Then it is again voltage controlled current source. Okay, so the same circuit can be modified here. So for the current source, okay, instead of voltage source, what you should have? Instead of polarity, I should have a arrowhead. I should have an arrowhead to represent the current. So this is my current source. Hence it is said to be a current source controlled by the voltage again. So 3V1, this is a current source. This is a current source controlled by the voltage variable. So voltage controlled current source. And the same thing, voltage controlled, sorry, current controlled voltage source. Okay, current controlled voltage source. So let me go ahead with change of variable. So let me go ahead here. So this is an current controlled thing. Let me write, instead of voltage across this 5 ohms, let me write this I as a current through the 5 ohms. First one is voltage source. Let me take plus minus, and it's an voltage source. It is controlled by the current. Let it be I. So let me take this 3I. So this is an voltage source, but it is controlled by the current. So it is said to be current controlled voltage source. Next is current controlled current source. So instead of polarity, I should have an arrow in the source. So here I'll take current source. It will be downward. So this is going to be a current source. It is controlled by the current parameter I, where I is nothing but the current flowing through the 5 ohm resistor. Hence, it is said to be current controlled current source. So altogether, you will be having 4 dependent sources. Okay, and keep in mind that dependent sources will be represented by the diamond symbol. Other than this, again the sources can be classified as ideal voltage source or ideal source and practical source. Okay, so ideal source, it don't have any internal resistance. Okay, the voltage will be stiff and it will be constant throughout. It won't decay, or the voltage value won't change with respect to time. That is said to be ideal source. And an ideal voltage source, let it be represented by plus minus and V, whereas a practical voltage source, it will be an voltage source, because it is going to change, the value is going to change. The voltage source will be having an internal resistance, whereas that internal resistance will be represented in series for an voltage source. Okay, this is internal resistance of the voltage source, whereas for the current source, this practical current source internal resistance will be represented by a parallel resistance. This is the current source. So for a practical current source, to change the practical current source to an ideal source, your Ri will be infinite for an ideal source, whereas here this Ri will be 0 for the practical ideal voltage source. So sources, again, ideal source and practical source. Keep in mind, none of the sources will be ideal. Okay, none of the sources will be ideal. And let us go ahead with the elements. What are the circuit elements and the sources? That is already done. R, L, C are said to be the elements. And then one example I can say, voltage controlled current source. For example, if I have n number of circuits as like a network, home 1, home 2, like that, that is connected to a distributed network. When I am increasing the loads in different home, okay, whatever this 230 volts that I am giving here, the supply, this is an voltage source. And when I am increasing the load at the home side, domestic home side, and there will be an voltage dip here. There will be an voltage dip from the source side. And this is again, this is a load, we will be talking in terms of current, because each load will draw its own current. And this is a current variable which is influencing the input voltage. So it is an voltage source, it is dependent on the load. I can say this as current controlled voltage source. I can say this is current controlled voltage source. And then coming back to Ohm's law, let me go ahead with the laws governing the circuit analysis. First, this is Ohm's law. You would have already know about it. What is Ohm's law? And when at constant temperature, V is directly proportional to I, where V is equal to IR, where R is the proportionality constant. This you know as the Ohm's law. And the second law for circuit analysis that we are going to discuss here is Kirchhoff law. Kirchhoff law, it is again you have two sort of law. One is KVL law, Kirchhoff voltage law, and another one is Kirchhoff current law. Kirchhoff voltage law is nothing but this is again law of conservation. So when I go ahead with the circuit, okay. So when I go ahead in a circuit or in a closed path, the sum of all voltages around a closed loop in any circuit must be equal to 0. Let me take a circuit like this. Okay, a circuit like this. So V is the input voltage. V1 and V2 are the voltage across R1 and R2. Okay. So, according to Kirchhoff voltage law, sum of all voltages around the closed path, around this closed path is equal to 0. Or they are said to be, I can say this applied voltage is equal to V1 plus V2. Or again, I can say V1, V minus V1 minus V2. Okay, this is going to be a drop. This will be equal to 0. Okay, this will be equal to 0. This is said to be Kirchhoff voltage law. And coming back to Kirchhoff current law, okay, Kirchhoff current law. So, at any node in a circuit, so this is a node. When a node is nothing but when two or more circuit elements are connected to a point. So 1, 2, 3. Okay, this three are circuit elements connected to this point, to the same point. This is said to be node 1. And again, this is R1, 2, 3 and 4. R3 and R4 is connected to this node. This is another node. This is 2. And see here, this voltage source R1, R2 are all connected to the same point here. This is node 3. And this can also be the ground node. Okay, this can also be the ground node. Usually, how will you choose your ground node is one end of the independent source can be chosen as the ground node. One end of independent source can be taken as ground node. Okay, so now we have three nodes. Third node is a ground node whose potential is 0. We can take like that. So now Kirchhoff current law is nothing but any node, okay, in any junction or node, the sum of incoming current will be equal to the outgoing current, or otherwise the sum of all currents in a node is equal to 0. Okay, so let me take this current will be incoming, this is again incoming, and let it be this 2 outgoing. So this is I1, 2, let it be 3 and 4. Okay, so I1 plus I2 is equal to I3 plus I4. I can say like this. This is Kirchhoff current law. Okay, so when we analyze the circuit by using Kirchhoff voltage law, and similarly we can analyze the circuit by using Kirchhoff current law. Okay, and before going into analysis, I need to tell what is mean by loop and mesh. Okay, loop and mesh. So loop and mesh. So what is the loop and mesh? Loop is nothing but, okay. So what is a loop? So let me assume a circuit like this. How many nodes I have here? This is node number 1, node number 2, node number 3, node number 4. And let me name it as A, B, C, D. Okay. So loop is nothing but when you go across the path, the node won't be encountered. The nodes in the path that we are moving in, it won't be encountered more than once. Okay. So 1, 2, 3, 4, and we will come across with 1 again, except for the first node where we start with. See, 1, 2, 3, 4, 1. Okay, we have started and ended here, except for the first node we have started with. Other nodes will be encountered only once. That is said to be loop. Okay, both loop and mesh are part of the circuit only. Again, I can say this as a loop. 1, 2, 4, 1 is also a loop. 1, 2, 4, 1 is also a loop, and 2, 4, 3, 2 is also a loop. Okay, is also a loop. Okay, we have 3 loops here. 1, 2, 3, 4, 1. 1, 2, 4, 1. 2, 4, 3, 1. Okay. And what is mesh? Mesh is a special part of the loop. Mesh is a special part of the loop that doesn't have any inner loops. Okay. Let me take this 1, 2, 4, 1. 1, 2, 4, 1 and 2, 3, 4, 2. So these two are said to be meshes where it does not have any inner loops. Does this has any inner loop 1, 2, 4, 1? No. This is the final part of your loop. Okay. So this has only one loop. Whereas see here 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. It is again in turn it is having two loops. 1, 2, 4, 1 and 2, 3, 4 and 2. It is again having two inner loops. Whereas mesh is a special part of the loop which does not have any inner loops. That is the difference between loop and the mesh. With this I'll stop today. We will continue with the analysis of circuit in the next class. Thank you.